So in tutorial 3, we're going to be looking at the trends in extreme weather events. And in particular, we're looking at climate change and its influence on the incidence and severity of extreme weather events, including drought. So when we first take a look at this graph here, it's really quite prominent to see that a lot of extreme weather events are increasing. So ignoring the red, which is geophysical events, we're really more interested in the green, blue, and orange. So meteorological events, which are tropical storms, thunderstorms, they're showing an increasing trend, and I've highlighted that as doubling. The hydrological events, which are floods and kind of mass movements, landslides and things which result from heavy rainfall, have more than tripled. And then in orange, these climatological events, extreme temperatures, drought, and forest fires, they also seem to be increasing. And if we look at the size of the graph down here compared to what we're seeing in these latter years, we can see more than tripling in terms of those events as well. But because that combines drought and forest fire, it's a little bit unclear about the patterns of drought. So we'll come back to that a bit later. So if we have a look at this graph, which shows something similar, we can see geophysical here, and we see the trend line, we see increase. But these hydrological, meteorological, and climatological events are showing an increase, and the trend line shows that. Of course, it's a noisy graph. There's some disturbances, there's some differences along the trend line, but the graph itself, the trend line, shows an increasing trend of extreme events. So if we draw our attention to maybe tropical storms, and there's perhaps a lack of research into this area in terms of climate change and the impacts on tropical storms. And there's also disputes about whether we'll see increased number of tropical storms in the future or not. But one study here shows, well, a significant global increase in higher wind speed storms. So the graph here, as you can see along the bottom, shows the increasing wind speed, and the trend line seems to suggest a growth in the frequency of high wind speed storms. So in this study here, it found in all storms with maximum wind speeds of 175 kilometers an hour, they saw a global increase in those storms. Storms of 200 kilometers an hour more than doubled, and storms with 250 kilometers an hour wind speeds have more than tripled. Although some of the trend may be owing to improved observation techniques, so we are able to record these systems much better, so that might account for some of the growth. It's still a really significant study. So this seems to make sense. If we're seeing a warming ocean, remember, oceans of 26 degrees Celsius or higher can lead to the formation of tropical storms. So if these oceans are getting warmer, well, then that should bring about increased sort of severity and sort of magnitude of tropical storms. Other scientists talk about wind shear, and wind shear is the upper atmosphere winds that tend to break systems apart. They prevent the systems from getting organized into tropical storms. And there would be increased wind shear under climate change conditions, so that could break up storms. So we might see less frequent storms, but more severe storms. And the data here shows that stronger systems are increasing. If we think about forest fires, this map here shows, well, the present situation and occurrence rates of forest fires. And what we're seeing as we move through a 2-degree global warming scenario or a higher emissions scenario, we see the likelihood of forest fires, of course, strongest in the Mediterranean, extending into Northern Europe, all areas increasing in forest fires. And so this kind of helps us, if we focus on this and consider California, well, we can see that climate change definitely appears, according to the data, to be having an impact on the frequency and the extent of forest fires. So on the graph here, we see the burnt areas up 5 times in California, and you can see it's very clear to see that the extent of these forest fires are getting greater, and they're getting greater in all areas of California. And this graph is really helpful. It's suggesting really that half of Californians' forest fires are now a result of climate change. It often plays out in the press a little bit about whether forest fires were, one, they're naturally occurring, and two, human land use management has an impact on them and perhaps has an impact on their severity. But that graph's quite clear. That's telling us that half of forest fires are caused by climate change. And so this graph as well, looking at Californian forest fires, shows the frequency of fires increasing, but it also shows you that the megaforests, the really large-scale fires that we've been seeing in the news this year and in recent years are increasing as well in frequency. When we think about droughts, it's not quite as clear. So the pattern of drought occurrence shows little change really over the last 60 years. Although the IPC forecasts that drought-vulnerable regions are expected to face more frequent and more intense droughts covering larger spatial areas. There is some debate amongst the scientific community. There's some criticism of the Palmer Drought Severity Index, and it's criticized by some groups as it's only based on precipitation and temperature change. So drought conditions are often the result of many complex interactions, including humidity, wind, land use change, and human management of lands. So droughts is definitely far more uncertain. And then we might be thinking that, well, drier areas, climate change is going to make those areas drier. We've also heard that wetter areas are going to get wetter. Another phenomena is the El Niño phenomena of the Pacific Ocean. So normally under normal conditions, you have the trade winds which push warm ocean waters from the West Pacific to the East Pacific. But with El Niño, what occurs is you get a weakening of those trade winds. You've got a warming of the ocean in the West and Central Pacific, which weakens those trade winds. And sometimes leads to a reversal of those trade winds. So you see that reversal pushing warm waters to South America, away really from the East Pacific. So a study by the international team and was published in PNAS examined 33 events from 1901 to 2017. So it's quite an extensive study of El Niño. And some of the key findings there was that climate change is disproportionately warming the waters of the Western tropical Pacific Ocean relative to the Central Pacific. So this is influencing trade winds, which tend to blow more strongly from cooler to warmer waters. And this warming trend is leading to more frequent Central Pacific-based El Niños and far more intense El Niño events in that area. So what are the impacts of El Niño? Well, quite grave. They dramatically change and shift patterns of drought and rainfall. So, are we going to see drought and its spatial distribution changing as a result of more frequent El Niños? And there's a big consequence here for human well-being. So, especially in terms of food security, crop failure, water security as well.